Scientists have studied the ozone layer in the atmosphere above Antarctica since the 1970s. In 1985, British scientists, working on data they had gathered at Halley Research Station on the Brunt Ice Shelf, discovered a large area of low ozone concentration over Antarctica. The ozone hole covers almost the whole continent and was at its largest in September 2006. The longest-lasting event occurred in 2020. The depletion is caused by the emission of chlorofluorocarbons and halons into the atmosphere, which causes ozone to break down into other gases. The extreme cold conditions of Antarctica allow polar stratospheric clouds to form. The clouds act as catalysts for chemical reactions, which eventually lead to the destruction of ozone. The 1987 Montreal Protocol has restricted the emissions of ozone-depleting substances. The ozone hole above Antarctica is predicted to slowly disappear. By the 2060s, levels of ozone are expected to have returned to values last recorded in the 1980s. The ozone depletion can cause a cooling of around 6 degrees Celsius, 11 degrees Fahrenheit, in the stratosphere. The cooling strengthens the polar vortex and so prevents the outflow of the cold air near the South Pole, which in turn cools the continental mass of the East Antarctic ice sheet. The peripheral areas of Antarctica, especially the Antarctic Peninsula, are then subjected to higher temperatures, which accelerate the melting of the ice. Models suggest that ozone depletion and the enhanced polar vortex effect may also account for the period of increasing sea ice extent, lasting from when observations started in the late 1970s until 2014. Since then, the coverage of Antarctic sea ice has decreased rapidly.